I want to share with you today my secret for working with large projects, and it's about planning. So there is an open source project called Taskmaster that does one thing, but does it really good. So let's start. The presentation is rather tactical and pragmatic, but let's start with a slightly high-level angle and a philosophical take. So I believe that the tools we use shape how we think and how we do our craft, and that everything evolves. So because the tools we use change constantly, they enable some new practices, and we are observing that with vibe coding. Thanks to Cursor or Lovable or Bolt, we can see the emergence of a new wave of people creating software. And it's all about the change. So some things get commoditized, like code generation, but at the same time, the value of certain skills is decreased, and some skills gain in importance. And I believe that higher level skills like understanding architecture, having a good judgment of how the good code looks like, or being able to plan in larger chunks, are those skills that are gaining the importance. So let's keep the vibes in vibe coding, but let's also introduce some engineering practices to the mix. Spec-driven development is something that has already been mentioned, and Cursor has recently introduced planning mode. And the great thing about this feature is that it seamlessly integrates with the workflows that users already understand. So it's not something that adds a lot of complexity, but it introduces even the notion of planning before doing to a lot of new developers. So here is how the feature works. First, Cursor does what it does best. So it's indexing your code base, and based on your request, it reviews your docs and asks some clarifying questions. And we have a human-in-the-loop step where you can clearly view the plan before it's implemented. And this step is very important because this is where your judgment comes into equation, and you can edit directly to those that are the steps that agent will execute. So let's see how it works in practice. And this is the difficult step. Okay, so in practice, we are entering our request. First, we switch to plan mode. Here, I wanted some non-trivial task, like creating some MCP server for marketing task. We get those clarifying questions. I answer them briefly, and the planning mode is being executed. Because it's a clean project, there is not a lot of context to understand, and we can see the markdown with project structure and some steps to follow. It follows my request to use specific library, and we can see the to-do action items. We can modify them, and we can start executing. And this is how it works by default. But the hidden feature, or not that obvious feature, is that we can save this plan before we execute that. And I will explain why it's important in a second. But for now, we are saving that plan, and we have this planning artifact that lives in our code base. So as a result, we have this action plan, and it's a great step because it introduces some planning to the equation. So at this stage, we are moving from vibes only to some vibes and some coding practices involved. But there is still a lot of, let's say, degree of freedom, some elements where things may go wrong with this prompt. And let's think how 10x better plan could look like. Perhaps it would have some more context. Perhaps the content about the action would be more structured. Maybe we would like to have some clearly expressed acceptance criteria or testing strategy for a given feature. That is not an overkill, but it's just enough to test this specific task we do. And it would be great if such plans could work with teams in multiplayer mode, with version control, and it would be great if they had CLI or MCP server. So this is what exactly what Taskmaster does. So we can think about Taskmaster as a project manager or a brain that keeps our intentions in check with reality. So it protects our projects from drifting, from expectations, and it helps to avoid what I call vibe bankruptcy. So it's when you wanted to do a thing, but after a couple of hours or iterations with Cursor agent, you have no idea what has happened, and even worse, you don't know how to revert the changes, and you have to declare bankruptcy and start from scratch. So let me show how. How to start working with Taskmaster. So on Taskmaster-dev, we have instructions. The first one is that we should install it globally, and then in our project we are initializing Taskmaster. At this stage, we are being asked some questions how we want our project to be set up. So, for example, we say that we want to keep track of our tasks in repository. We want to work with Cursor, so it will generate rules for Cursor to understand Taskmaster. We can select more than one coding environment, and then we select a language model. Or even 3 language models, because we can assign different LLM to different tasks. The most important one is general one. It's responsible for deconstructing your PRD or your intentions into tasks. But there is also a research model, and we can select from the huge variety of options. And what I have chosen here was Gemini Pro, but served from Gemini CLI. So the price is good because it's a free model for now. We can select different models for as a fallback model. So for example, here I'm selecting OpenAI GPT 4.1, but through Open Router. With that we are ready to go, and as a result we get in Cursor folder the rules how Cursor should work with Taskmaster. But one of the cool additional features we get is this instruction how our system could self-improve. So every time we face some challenges or some debugging loop, we can just tag this Cursor rule in our agent session, and it will understand what went wrong and what adjustments to our rules we need to implement to avoid that. And this is a config file where those LLMs are defined. And yeah, I will maybe speed up, but later I decided that maybe I won't use OpenAI's model, but rather I will select something that is different from OpenRouter. So I just search for this model. The recent one that works well with coding is GLM from the Chinese lab. So I just check how to how this model is defined, and I override the default settings that were generated during the project initialization. So at this stage, we have LLMs defined. The only thing to set up is to just create .env file with keys to LLMs. And with that, we are good to go. So we have, by doing that step, we now have CLI that comes with Taskmaster ready to be used. We have MCP, we have those cursor rules, and we have the basic structure for repository. And we can manage the costs because we have selected the LLMs that we want to use. So right now we are, this is the typical workflow. To start with Taskmaster, we are first generating the plan. So this is this task breakdown. And then we can review it and review specific tasks. And we can execute one by one in Cursor. And that's how it looks like in practice. So the first comment, if we imagine that we don't have Cursor agent available and we don't maybe we want in different coding environment, or we want to work manually from the command line. The first command line we need to execute is parse PRD, and we just pass a path to our document where PRD is drafted. And as a result, we get this breakdown that has priorities assigned to all tasks. Tasks have dependencies, so we can see that task 2 is of a high importance, but first task 1 need to be completed. And yeah, then we can zoom in and zoom out and see the whole project plan. So we can review those tasks and modify them or adjust the plan. And the last thing to do is run Taskmaster next. And what it does in the background is it's reviewing the current plan. It says where we are in our project with statuses, which tasks are completed, which are not done, which have still pending dependencies, and based on that, it defines what's the next best step to for us is. This is how a single task view looks like. So you can see those elements we already covered, like priority, dependencies. Complexity is a great one because it gives us as a users good understanding where the bottlenecks may be in the execution, or where the tricky parts of the project are. And if some tasks are complex, it makes sense to break them down into subtasks, so they also then appear at the bottom. And the great thing that goes well with the previous session is testing strategy. So maybe we don't need super hardcore, strictly defined rules for some small project, and it can also be reflected in this area. So when we just pass this task to agent, it does what's what makes most sense. So the initial selling point for Taskmaster was that it's a command line environment, but I think that we can say that people come for CLI but stay for MCP. So this is what I mean. You just activate the CLI that was installed with this initialization step, and in agent session we can rather than executing those commands I showed you one by one, we can just that we want to parse PRD, and this is where our initial plan from Cursor comes into play. I think it's hello. So our task for Cursor agent was to parse PRD, and as a result, you can see that in Taskmaster tasks folder, we have a JSON with this dependency graph and all the tasks defined. And then we can execute those commands I showed you before to understand the high-level plan or specific tasks. But because Cursor has already those rules that were installed with Taskmaster, they define the workflow. So it knows that after parsing, the next logical step is to quickly describe where we are with the project and execute this Taskmaster next command. So before even we ask, it suggests what the most practical action should be. Okay, so I think that the new workflow that is now possible is combining the both worlds. So we can use the Cursor plan mode for vibing and brainstorming. It's great at understanding our short intents and discussing what we want to do. Those clarifying questions will make sure that the PRD is on point of what we intend for. And once we save this plan, we can use it as input for Taskmaster. And then, we move from planning to the execution stage. And during the planning, we will find that our plan is changing. And that's by default how Taskmaster works, is that it's not an edge case that our expectations change during the project. It actually assumes that it is a default mode, that the plan will change. And for that, we have specific commands for updating single task or tasks with future dependencies. So it's really great for this self-improvement loop. So to speed up, there are some more advanced things like analyzing complexity, avoiding vibe bankruptcy, and handling merge conflicts. So we can set the threshold for complexity. And we then run complexity analysis. And based on that threshold, it will suggest for all tasks that are above, how to break them down into smaller tasks. So we can see that the most complex task was writing the documentation, because this project was rather simple, and to make sure it's really executed well, it should be broken down into 4 tasks. So to avoid this implementation drift, we also have an option to update a specific task with a prompt. So we just need to express our intent For example, we are switching the database, or we are using different design pattern, or whatever. And then all tasks, not only this specific task is being updated, but also the future tasks that depend on that one. So that's really a really smart approach for managing the plans, because otherwise we would change probably somewhere in our document that part manually, but it would be quite difficult to go upstream and understand what other parts are affected. So if we are working with teams, we may find that our task JSON is different than the one that is already in repo. So to avoid that, there is a feature that moves your new tasks. If they have the same IDs, they are being moved, so the conflict is being avoided. So some pro tips. Rather than learning CLI commands, I would advise to just start with MCP, and after 3 minutes of scanning the documentation, you will have a good idea how to work with Taskmaster. Use version control. It's a good practice to commit at least after each major task is completed. So you can always jump to what was working okay. There is an option to tag different tasks and group them by tags. So we can use that to organize the work by features or by themes. And then there is a feature that is not used often, but is very handy for validating the dependencies. So we may modify some small pieces of the plan along the way, and then we just run this validation. So key takeaway is let's use tools that are aligned with our priorities. If we are building complex projects, planning is probably super high leverage task. So we may use a tool that does this part really well. But by combining what Cursor has just released with Taskmaster, we get a really good stack for quite mature AI engineering practices. So as a result, we have added a lot of engineering and coding to vibe coding practice. So yeah, let's make planning great again. Thanks.
Thanks, great presentation. Have you seen any workflows that there is like a single Taskmaster instance that makes the task for a team of few developers, probably connected to linear as a layer that connects to the task?
Yeah, so I think I even mentioned it here that because it's MCP, it works well with other MCPs in one session. So that's by default, by design, how MCP works. So it's a great tool for teams. And I don't have a lot of experience with working with large teams, but I rather use it with 2 or 3 people. And everyone has its own Taskmaster on local machine, and it's not part of the code base. The part of the code base is are just those artifacts that Taskmaster generates. So this task file is what's being pushed to repo, not Taskmaster itself.
Maybe 2 questions. So I'm very interested in which models do you use in your daily work when you use this Taskmaster tool? So it seems like the performance of Taskmaster really depends on ability of the model to use to do tool calling. So which models do you use?
Yeah, I like Gemini model, so I use the Pro model as a default one for those general tasks. And for the research mode, I'm experimenting with different models, and I see that people recommend using Perplexity for that by assuming that it's good at grounding research in web search, and it does research part really well.
How does Taskmaster tool perform in large code bases? So it seems to me I tried to use those in the past. I think it was called Cloud Taskmaster or something like that.
Mm-hmm. So is this one?
Is this the
yes,
same?
Yes, yes.
Yeah. And it seems like it breaks down when the code base grows really large. It seems that the model just ignores the rules that are embedded in the Taskmasters any kind of files.
Yeah, so there are two failing points. So one is maybe more about cursor following cursor rules, how we design the flow. And in this area, I found that clearly translating your expectations of the flow into rules, but keeping the rules small and very direct is what helps. But by working with this flow a lot, I default to just explicitly mentioning the task rule I want to, the cursor rule I want to follow at the specific stage. So, for example, I have TDD rule that defines that what should happen before we even start coding, and by just starting with saying, okay, I just say next. So it already knows that next means execute the next task. So I just write in the agent window next and tag this rule. So it knows that it should combine. So it's rather not a full auto mode, but when we know those failure points, we can direct our attention and avoid those mistakes. And sometimes just mentioning that explicitly gives you a comfort that you also understand what is happening, and you can control if we are not closing, getting closer to this vibe bankruptcy state.
Let me maybe close with that question. Thank you, Łukasz, once more, for a round of applause.